question is, the stone is thrown vertically upward with a speed of 15.5 meters per second from the edge of a cliff, 75 meters high. I've represented a cliff like this, and the stone is thrown from this point, 15.5 meters per second upward. The question is, how much later does it reach the bottom of the cliff? Now, what this means is we're supposed to calculate the total time of flight. That's the time it takes for me to go from the edge of the cliff to the maximum height here, where the velocity will be equal to 0, and then all the way down to the bottom of the cliff. I'm going to represent this as T1 and this as T2. So to calculate T1, we use this formula. A equals V minus U over T. A here will be acceleration due to gravity. V will be the final velocity and U will be the initial velocity, and T is the time we're looking for. So here, A equals G and equals to minus 9.81 meter per second squared. And V here will be equals to 0 meter per second. U equals 15.5 meter per second. And T is what we're looking for. So here, minus 9.81 equals 0 minus 15.5 over T. So T will be equals to 15.5 over 9.81 equals to 1.58 seconds. This is T1, of course. Now to calculate T2, we use this formula. To calculate T2, we first separate the time up to this point, because we know that the time it takes to get to time of flight from here to the maximum height will be the same time, exactly the same time, from this point, from the maximum height back down to the same point. So we can adjust this diagram a little bit. So we see here that we have another T1 here and then T2 downward, because it will take the same time. The time here will be equal from here to here, and the velocity will also be equal, but in the opposite direction, 15.5 meters per second downward. That will be the velocity of the stone when it reaches this point. So we can use that to calculate T2. We use this formula. S equals ut plus half at squared, when S is the distance, U is the initial velocity, which is 15.5 in this case. T is the time we're looking for, and A is the acceleration due to gravity. I'm going to write our parameters here. S equals 75 meters. U is the initial velocity, which is 15.5 meters per second. A equals to G equals to 9.81 meters per second square. And T is what we're looking for. So coming back here, we have 75 equals 15.5 T plus half 9.81 T squared. I'm going to separate this here so we don't make a mistake. Calculating this, we have T equals 2.64 seconds. T equals 2.64 seconds. Now to find the total time, this is T2, of course. To find the total time, equals here in this case it will be 2 times T1, 2 times T1 plus T2, which is 2T1 plus T2 equals to 2 times 1.58 plus 2.64 which is equals to 5.8 seconds. Now for the second part of the question, it says, what's the speed just before it hitting the bottom? That's the ground here. So we're looking for the speed here, v. And we know that the speed here at this point, when it gets to this point, when it's coming back down from where it was thrown, will also be 15.5 meters per second downward. So here we need to find the velocity just before hitting the ground, and we can use this formula: v squared equals u squared plus 2as. V is final velocity using initial velocity, a is acceleration due to gravity, which is g, and s is the distance, which is 75 here. So then we have v, which is what we're looking for. V squared equals u squared, which is 15.5 squared, initial velocity here, plus 2 times 9.81 times s, which is 75. Calculating this, we have v equals to 41.4. Sorry, 41.4 meters per second. Now to the last part of the question. It says, what's the total distance it traveled? What total distance did it travel? So to find the total distance it traveled, we need to find the distance it took to go from this point to the maximum height. We call this distance s, and all the way back down the same distance, and then from this point to the bottom, which we know is 75 meters. So to find s here, we use this formula: v squared, same formula we used in the last question, which is v squared equals u squared plus 2as. And this, from this we have the final velocity here. We're modeling the path from here when it's going up to the maximum height. So the final velocity here will be 0 squared equals u squared, which is 15.5 squared plus 2 minus 9.81 s. Solving this, we have s equals to 12.25 meters. To calculate the total distance, we have total distance s equals 2 times s. Sorry, total distance. I need to remove this s from here. So just total distance. We're not going to represent that s because we've used s there for part of the distance. Total distance equals 2 times s, which is this distance, 2 times this because it goes from here to the maximum height, and also that same distance down, plus 75. So 2, 12.25 plus 75 equals 24.5 plus 75 equals 99.5 meters. Final answer.